Hello, Assalamu alaikum, everybody. Let me share my screen. Um, okay, you guys should be able to see my screen now. This is lecture 23 of discrete structures, and we are continuing with the concept of graph. हमने start किया था a couple of lectures back, and we're going to spend a couple of more lectures on this as well. हमने last time, so there is an announcement कि हमारा जो exam है, we have decided it's going to be on Monday, January 18th. So we will have a lecture today, on Monday, and next Thursday. And after that, you will have exam on 18th of January. Okay, so we don't have an exam next Thursday. We have an exam the Monday after. All right. And the content remains same. हम वही counting और graph दो main topics हैं जो हम cover करेंगे before that exam, and that's going to be the syllabus for the third exam of this series. And then we will have a couple of lectures, probably 3 or 4 lectures on discrete probability. But we won't have enough time to give you a homework for that. I will give you ungraded problems जो आप solve करेंगे, but they won't have a grade. So this is going to be the last homework जो हम आज आपको देंगे. Okay, so in total you will have 5 homeworks. The least score for each one of you will be discarded. Okay, so we will count only the 4 best scores that you managed on 5 of these homeworks, and that's going to be it. Discrete probability ka you won't have any homework, but you will definitely you may see some problems from discrete probability on the exam, on the final exam. Okay, so let's continue with the graph. Let me summarize जो हम last time कर रहे थे, couple of concepts जो हमने देखे थे. We saw the concept of a bipartite graph. We saw the concept of a complement graph. What else? Graph isomorphism हमने देखा था. Or labeled and unlabeled graphs. Minimum degree, maximum degree. Or what else was there? Yeah, that's about it. Okay. Graph isomorphism का problem मैंने आपको, I gave you the intuitive sense of the problem, and probably I defined it formally as well. लेकिन मैंने उसको लिखा नहीं, तो let me do it. Okay. उसके बाद we'll move on. This is the problem that I left for you to do. Did anyone manage to solve this problem? So the problem was that if you have a graph and it's isomorphic to its own complement, then the number of vertices and that graph can't be arbitrary. Okay, so for example, you can't have let me see, 6 vertices in such a graph. Okay, so that was the question, and you needed to prove this. But let me just quickly define the graph isomorphisms formally for you. Okay, and then we'll move ahead. Meanwhile, let me know if any of you have tried solving this problem. Okay, it's actually not that hard. If you did try it, so you must, you can't be very far away from the solution. Okay, so graph isomorphism ko, let me define it formally in a sense that it will be in the language that we have studied. Okay, so the statement is that you are given 2 graphs, given 2 graphs, G1 is equal to V1 comma E1, and then you have G2, let's call it V2 comma E2. Okay, we say that G1 is isomorphic to G2. This is the sign for isomorphism. If there exists a bijection Let's call this bijection pi from V1 to V2. So there is a bijection from the vertex set of the first graph to the vertex set of the second graph, such that UV is an edge in E1 if and only if, okay, so this implies both sides. The function of U in V2 and the function of V, so the range of, so the element which V is associated with, ये वाली जो चीज़ है, this must be an edge in the second graph. Okay. This isn't hard. Last time भी आपने देखा था, but I wanted to define it formally as well. Okay, so this is formally what it means for two graphs to be isomorphic. We say that two graphs are isomorphic if there exists a bijective function from the vertex set of the first graph to the vertex set of the second graph, such that whenever there is an edge between two vertices in the first graph, तो फिर उसके एसोसिएटेड जो वर्ड्स सेकंड ग्राफ में है उनके दरमियान भी एच होना चाहिए. ओके, अगर आप सेम ग्राफ ले लें तो इसको देखना बहुत आसान है. सो फॉर एग्जांपल इफ यू हैव अ C4, इसमें आपके पास ये 4 वर्टिसेस हैं और देयर इज अनदर C4 और इसके अंदर आपके पास वर्टिसेस हैं, लेट्स से A, B and C and D. Okay, तो फिर यहाँ पे bijection is absolutely clear that 1 goes to A, 2 goes to B, 3 goes to C, and 4 goes to D. Actually, there could be more than one bijections which work, such that for every edge in the first graph, corresponding vertices have an edge in the second graph as well. Okay, and vice versa. So for example, 1, 2 is an edge here, so फिर 1 is A and 2 is B, so AB must be an edge there. Okay, so this is what a graph isomorphism means formally. Well, last time मैंने आपको informally ये कहा था कि अगर आप इन दोनों ग्राफ्स के लेबल्स हटा दें, make this an unlabeled graph and make this an unlabeled graph, they must look exactly alike. Okay. All right, let's move on. Any questions?
No, sir.
No, sir.
Okay, so did anyone try solving this problem?
Yes, sir.
Did you?
Yeah.
Okay. Did you manage to solve it? हो गया?
Yeah, sort of.
Okay. चलें ठीक है. So here's what I'm going to do. I'm going to not solve this problem. Okay. This is going to be an exercise on your homework today. Okay. इसके अलावा उबैद, let me give you a couple of problems. हमने last time भी discuss किए थे. आप इसको homework में कर सकते हैं. Exercise 2 is counting the number of paths. So it's the maximum number of paths in a graph. Okay. Exercise 2 is 3 is a related a number of cycles. The maximum, actually let's do it both. Okay, maximum bhi kar lo or minimum bhi kar lo. What's the maximum number of paths that you can have? What's the minimum number of paths that you can have? What's the maximum number of cycles that you can have? And what's the minimum number of cycles that you can have? Does it make sense to have a tour ka bhi kar lo? Okay, exercise 4, this will help them remember the definitions of these problems. Okay, so tours, how many tours can you have? Okay, और क्या हो सकता है? Trails का, okay, so for now this is it. Okay, बाकी problems हम देखेंगे. All right, so here's the first puzzle of today. You're given a k-regular bipartite graph where k is more than 0, and the claim is that इसमें जो bipartite graph की partitions हैं वो unequal size की नहीं हो सकती. You can't have the scenario कि आपके पास एक bipartite graph है, उसमें एक side के ऊपर you have 2 vertices, in the other side you have 4 vertices, and this is a k-regular graph. That's not possible. Okay. And who is going to tell me why this is not possible? Remember, it's not a complete graph, okay? It's not necessarily a complete graph, ज़रूरी नहीं है. But even then, the claim is that a k-regular bipartite graph can't have unequal partitions. I don't know if let me remind you, k-regular means the degree of every vertex vi is equal to k.
सही है
All right.
खुद ही नहीं
Yeah.
होगा फिर कि अगर डिग्री सारों की सेम है तो एरोज मतलब सारों से सेम आ रहे हैं मतलब और जो बाइपार्टाइट है मतलब उसमें मतलब ये तो खुद ही नहीं प्रूफ हो जाएगा क्लियरली.
नहीं, खुद ही नहीं होगा, एक कुछ ना कुछ कहना पड़ेगा. कहो जो कहना चाहते हो.
सोच रहा हूँ सर.
सर ये दोबारा
Okay.
एक्सप्लेन कर दीजिए.
और स्टेटमेंट लिखी हुई है अनस. यू हैव अ k-regular bipartite graph. The claim is कि उसके पार्ट्स का साइज सेम होगा. You can't have ये सिचुएशन अकर नहीं करेगी. This is impossible.
ओके सर.
इसमें बाइजेक्शन नहीं होगी.
Okay.
Sir, I guess इसमें ये होगा कि we can say that a k-regular graph contains k plus 1 vertices.
No.
So
No. So देखो अब कंप्लीट ग्राफ से उसको वो कर रहे हो, कंफ्यूज कर रहे हो. So for example, this is a zero regular graph. Okay. Similarly, I can have so this is, for example, a 2 regular graph. Okay. So regularity does not say anything about the number of vertices. So you can have a 2 regular graph जिसमें 1, 2, 3, 4, 5 यहाँ पे edges vertices हैं, right? Similarly, you can have a 2 regular graph जिसमें सिर्फ 3 vertices हैं.
right, I got it.
Okay.
सर अगर हम इसको दो पार्ट्स में ऐसे डिवाइड करें कि x और y को लाइक वर्टिसेस असाइन कर लें कि x के पास फॉर एग्जांपल m वर्टिसेस हैं और y के पास n है.
Okay.
तो लाइक फॉर the graph to be k-regular bipartite graph, it must be that m minus n into k is equals to 0 जो आपने हमें वो इक्वेशन बताई थी. So
So एक second. The thing is that equation was needed for maximum number of edges. Okay. उसके लिए हम complete graph construct कर रहे थे.
okay, तो ये इनकम्प्लीट ग्राफ है.
So यहाँ पे किसी ने बताया नहीं कि ये complete graph है. हो सकता है ये complete हो सकता है ये complete ना हो. Okay. So it's possible it's complete. It's possible that it's not complete. Your proof should not assume that it's a complete graph.
Okay.
Okay. But the start was fine. Assume करो कि आपके पास एक k regular graph है, उसके पास
तो सर
x में
अगर
आपके पास m vertices हैं और y में n vertices हैं. Yes, go ahead.
कॉन्ट्रडिक्शन से इसको प्रूव कर सकते हैं कि लाइक इफ there is one edge that has more than k degree that has a degree of more than k like k plus 1. तो अगर if n is greater than m or m is greater than n, there must be at least one vertex with a degree of at least k plus 1.
Just hold on a second. ये कौन है? ईमान है?
Yeah.
Okay, ईमान, the thing is कि देखो आप क्या कर रहे हो, आप ना उसका जो hypothesis है उसको contradict करने की कोशिश कर रहे हो. इसका यहाँ पे hypothesis ये है कि this is what's given कि it's a k regular graph, it's bipartite और k is more than 0. This is hypothesis. ठीक है, इसको लेके आपने prove करना है कि x is equal to y. Okay. So what you do in the proof by contradiction, आप इसको true assume करते हो and then you assume that this part is false.
Yeah.
Okay. So ये वाला part है, this is by definition true. You assume कि k regular है, every vertex has k degree. Okay, it's a bipartite. But this part is not true. Okay, x is not equal to y. That's how you start proof by contradiction. Do you want to try again?
Yeah. Okay.
Okay.
So if like x has n edges and sorry, the degree of ax is n, and for b it is equal to m. So let n is not equal to m,
Okay.
and since it's a k degree graph, so the distribution must be that k multiplied by n edges from x to y,
Yeah.
and multiplied by m edges from uh, y y to
Perfect.
x.
Yeah.
And
Yeah.
since n is greater than m, there will always be a vertex x with a degree of at least k plus 1.
Yeah. That sounds good. That's it. So let me just rephrase it. Good. So the thing is, हमने assume किया कि there are k regular, all vertices are k regular, and x and y is equal. But by contradiction, assume करें कि m and n are not equal. Okay. So what we know that the number of edges incident on these vertices would be k times m. Okay. Because there are m vertices here and everyone has degree k. Okay. And similarly, the number of edges incident on the y part would be k times n, because there are n guys here and everyone has degree k. The thing is, यहाँ पे between these vertices कोई edge नहीं है, और between these vertices भी कोई edge नहीं है, which means all the edges here would be incident on the vertices here, and all the edges incident here would be incident on y as well. So the number of edges in here must be equal to the number of edges in there. Okay, which means that k times m must be equal to k times n. Okay, which implies that m must be equal to n. And that's it. That's your proof. Okay, m and n is definitely equal. It's not आपका assumption जो था कि जिसमें आपने कहा कि m n के equal नहीं है, that's not possible. m and m must be equal. Okay, so once again, this is proof by contradiction. आप assume करते हो कि this is not true, कि एक partition बड़ी है और एक partition छोटी है. But the number of incident edges on both parts must be equal because it's a bipartite graph. You can't have कि यहाँ से दो edge आ रहे हैं और वहाँ पे जाके ये somehow तीन हो जाते हैं, right? That's not possible. But since everyone has degree k here and here as well, so that's not possible. M and m must be equal. Are we good? Questions, people? So this wasn't really an involved question. I assume कि इस तरह का question आपके पास अगर exam में आ जाए तो you should be able to do this. It should not take a whole lot of thinking to be able to solve this question. Does there? Is there some thinking involved in this thing?
Not much.
Yeah, you should be able to do it in 5 to 10 minutes, right?
Yes, sir.
All right.